So, from this figure you see that suppose here you write omega t means phase angle, So, it is a wave from S1 and this is your crest, the amplitude is maximum at crest. Then this is your trough. So, this is your wave from S2 and here it is say y1, it is y2, then the resultant wave is your resultant wave. So, this is resultant wave. Here there is crest and the amplitude is A2. So, this will be crest falls on the crest. So, the amplitudes just add up. Here there is trough minus A2 minus A1. So, they also add up like this. This is trough and this phase angle like this 0, 180 degree, it is 360 degree, it is 270 degree, 0, 180, 270, then 360, 0, 180, 270, this is 90 degree, then 360 degree. So, from this graph number 1 we can say, graph number 1, we see that when crest falls on the crest, the principle of superposition y is equal to y1 plus y2 makes resultant amplitude A1 plus A2. Similarly, when trough falls on the trough, it is minus of A1 plus A2. But the intensity, as you know, intensity is directly proportional to the square of the amplitude. So, here the intensity will be proportional to A1 square, it is proportional to A2 square, it is proportional to A1 plus A2 whole square. So, that we are investigating now. So, from this we see that since intensity, that is I, there is a formula, that is 2 pi square n square a square rho v. The symbols are density, speed of light, n is frequency, like that, or I proportional to a square. So, for the fast wave from S1, I is equal to k A1 square. Then similarly, I2 will be k A2 square. So, I1 by I2 is your A1 square by A2 square is equal to R square, where R we say amplitude ratio, R is equal to amplitude ratio is equal to A1 by A2. From the law of parallelogram of vectors, comma, we know that A is equal to A1 square plus A2 square plus 2 A1 A2 cos phi. Phi is the phase difference that will come to. So, A is equal to A1 square A2 square 2 A1 A2. Naturally, when phi is equal to 0 degree, it becomes maximum. Phi is equal to 0 degree, it is maximum. When phi is equal to 0 degree, or you can say 0, 2 pi, 360 degree also it is possible, etc. A is equal to A1 plus A2 is equal to A max. So, I max will be proportional to A max square. So, implies I max is equal to constant of proportionality k, then A max square. So, this is your or saying this is A1 plus A2 whole square. This is equation number 4. So, from this equation 4 and equation 1, if you divide I max by I1, so what you get? K cancels. So, it is A1 plus A2 by A1 whole square. Then suppose A1 and A2 are equal. Suppose A1 and A2 are equal, then what happens? If A2 is equal to A1, comma, then I max by I1 is equal to 4. So, I max is 4 I1. That means, the brightness of the bright spot of the interference pattern is having intensity 4 times that of the intensity due to one wave. Clear? So, therefore, from this we see that the brightness of the bright spots is quite high. Then if the if the crest of the wave from S1 will fall on the trough of the wave from S2, comma, then A becomes minimum is equal to A1 minus A2, as shown in graph number 2. So, you see we will make another graph number 2, where you see so this is trough. This is crest. Like that. So, this one will be because crest of falls on the trough, there is algebraic addition. So, it is A1 minus A2. So, in that case what will happen? This I minimum, intensity minimum, is equal to K A1 minus A2 whole square. And if A1 is equal to A2, if A1 is equal to A2, comma, then I minimum is equal to 0. If I minimum is equal to 0, then perfect dark spot is formed, perfect dark spot is formed. If A1 is nearly equal to A2, then slightly dark point, but with brightness a little bit there. But if A1 is equal to A2 exactly, then I minimum is equal to 0. Usually it is not exact. So, therefore, we can develop a formula which is useful, that is I max by I minimum. That means, what is the ratio of the maximum and minimum intensities. So, I max by I minimum is equal to A1 plus A2 whole square by A1 minus A2 whole square, and that is now A1, suppose you divide by A2, A1 by A2 plus 1, then whole square. You divide the numerator by A2, inside is by A2, and the denominator also by A2. And A1 by A2 is R, that is amplitude ratio. So, it becomes R plus 1 minus by R minus 1 whole square. That is problems are asked on this formula, that if intensity ratio is given, then find the if intensity ratio is given, then find the ratio between maximum and minimum intensities. Sometimes that is asked. Then we come to the conditions of interference. Conditions of interference. Mainly there are three conditions to be satisfied, to get interference. So, first condition is your light must be monochromatic. The light to be used must be monochromatic. So, what is the meaning of monochromatic? Monochromatic means single color and single wavelength. Single color and single wavelength, and how to get these things. So, example is sodium vapor lamp. So, it is just like a bar light where mercury gas is used, but for sodium vapor lamp, sodium vapor is used. Then that sodium light, when analyzed by spectrometer, is found to consist of two lines of wavelengths 5890 angstrom and 5896 angstrom. So, only the difference is 6 angstrom. Therefore, the average of these two is lambda bar is 5893 angstrom, and that is almost monochromatic. So, therefore, for all scientific research and the experiments, this sodium vapor lamp is used. So, that satisfies the monochromatic condition necessary for interference. Then we come to the second condition. Second condition is your the light waves obtained from S1 and S2 must be coherent. So, this is a crucial point, because people placed two sodium lamps near S1 and S2, but interference was not observed. So, that shows that the source of light S must provide waves for S1 and S2, because the initial phase difference should not exist at the time of starting of the waves. So, therefore, single source S be used with the condition with SS1 is equal to SS2 will satisfy this condition, will satisfy the coherent condition. People tried with two sources, but failed, coherent sources. Then we come to the third condition. Third condition is the path difference between the light waves, starting from S1 and S2 must be an even multiple, of lambda by 2 for constructive interference. Constructive interference means bright spots. For bright spots, the path difference. So, what is the meaning of path difference? This is the screen. This is the point on the screen. Then S2P minus S1P is equal to delta, that is path difference. So, it says that the path difference, depending on the position of the point P on the screen, the path difference must be even multiple of lambda by 2, that has to be satisfied. And for dark spots, the path difference will be odd multiple. So, the path difference between light waves starting from S1 S2 must be an odd multiple, must be an odd multiple for destructive interference. It is called destructive interference, means formation of dark spots. For destructive interference in dark spots. That means, for dark spots the path difference must be an odd multiple of lambda by 2. So, this can be derived very easily by means of a vector diagram. So, what is the vector diagram? Because the amplitudes, there is a wave, so the amplitude is a behaves like a vector. So, if you say that wave from S1 is given by the equation A1 sin omega t, wave from S1, then S2 is the wave will travel a greater distance. So, the wave from S2 has to be represented by A2 sin omega t minus phi. So, this is the angle phi and this is the sin omega t minus phi, this is the direction. So, what you do? You make a parallelogram to find the resultant amplitude A. So, A will be just from mechanics, it is A1 square plus A2 square plus 2 A1 A2 cos phi. Then what is phi? How to get phi? We see that from the theory of waves, for path difference lambda comma phase difference is equal to 2 pi radian. So, for path difference 1, phase difference is equal to 2 pi by lambda radian. Then for path difference delta, that is your S2P minus S1P, phase difference is equal to 2 pi by lambda delta, and that is your phi. So, with this idea you can say that for bright spots phi will be 2n pi, where n is equal to 0, 1, 2, 3, like that. general. 0 degree we discussed previously, it is one value, then 2 pi is also same value, like that. So, this is the condition for bright spots. Then if you write 2 pi by lambda delta, it is 2 n pi. So, pi pi cancels. So, that you get delta is equal to n lambda, but we write it as 2 n lambda by 2, that is even multiple of lambda by 2. In the same way, for dark spots, your phi will be 2 n plus 1 pi, where n is 0, 1, 2, 3. So, 2 pi by lambda delta is equal to 2 n plus 1, like that. So, delta you get as 2 n plus 1 into lambda by 2, that is odd multiple of lambda by 2. So, for bright you write dark, for dark spots this will be 2 n plus 1 into pi, then so it will be 2 n plus 1 2 n plus 1, that is your odd multiple of lambda by 2. So, this is the third condition that we will use in the next class to find the fringe width expression.